In the previous video, we set up a Docker development environment, which was using Docker files and Docker Compose to spin up a full environment that updated in real time while you developed. But that environment is not great for production. When we want to go to production, we want to make a few changes. And so I'm going to walk you through those. And so that's basically, we are using default Docker images. When we said from as our base, we are using Node, Python, Nginx. And those images by default are really big. And so you don't really need that usually, especially for production. So there's other versions of these images that are slimmed down, much smaller. They have bare minimum requirements. And so the two that I'm going to be looking at today are Alpine, which is a 5 meg Linux distribution that does have a package manager and everything built into it. So your Docker images can be very small. And most maintained or official Docker images have a tag for an Alpine distribution. And then if you would like to use a slimmed down version of Debian, there's Buster Slim, Stretch Slim that you can utilize as well. So I'm going to show you how to slim down your Docker images and then prepare them for production. So when we're in development for Python, we might have C libraries and we're going to have build tools. Same thing for Node.js. We're going to be able to generate those node modules. But in production, we just want to ship up the HTML files. We don't want to have all these build tools in our image, because when we do deployments, the smaller the image, the faster the deployments. So let me show you exactly what I'm talking about. So in the previous video, this is what we worked on. So we created a Docker Compose file, and you can see this is mounting local volumes so that we got that real-time code environment. We don't want to do that in production. Everything will be inside the image. So we're going to create a different Docker Compose file that is only for production. And then if we look at the web file, the Docker file, you can see with this, we are running yarn start. And so we are spinning up a development web server that had fast reloading, module reloading, so it had a file watcher that anytime those files change, it would reload for development. In production, we don't want that. We just want static HTML files. And then same thing for API. You can see here, we're running the Poetry install, but we might have C dependencies in here. So when you run this install, it's going to compile all of those C dependencies. And we don't want all those C dependencies deployed to our production instance. We'll run the build, we'll install it all, but then we'll create a binary distribution that we can ship up with our image. And so if you look at this, it says from Python. And then if we look at the web one, it's going to say from Node. And then same thing for the Nginx one. From Nginx. We're going to switch all of these to be the slimmed down Alpine distribution. So we'll have to do some modifications because they're going to come with less stuff, but it's not a lot of work and it's definitely worth it. So instead of doing this in front of you in real time, because my last video was 40 minutes, I want to try to make this one a little bit faster. I've done most of the work already and I just want to show you the modifications I made. So the first thing you're going to see is with the Docker Compose file, I have a dev and I have a prod. So if you see this, what I've done is instead of telling the development environment to be based on an image, I'm telling it to build automatically, because then you can say Docker Compose build and it'll build all of those images for you, and it's going to set up those volumes like we did in the previous one. And that's pretty much the only change I made. One big thing here, this is just a trick with development environments. If you have a node modules locally, it's going to make that volume and it's going to use those node modules. But we really don't want those node modules up in our container. we still want to generate them within the environment of the Docker container. And so I'm just creating a mount after our volume that says overwrite the node modules. Even if I had some locally, ignore that. We're going to generate them within the container. And then if we look at the prod, it's much smaller. We're just saying use these images, pull them down and run them. And then we're just setting up a couple of environment variables. And this can be for your database, for your host, whatever. You pass environment variables into the container so that it can set up configuration properly. And then the next thing we did is modify each of these containers. So if we look at Nginx, what I did for that is I changed it to the Nginx Alpine image. And if you want to see what this looks like, these were the ones we built in the last video. This is, the Nginx alone was 133 megs. The web was 1.2 gigs, and the API was 1 gig by itself. So now I've rebuilt these on Alpine. And I did some more modifications that I'll show you in a minute. But you can see we went from over a gig to megs. The API one's a little bit larger, but in general, we're less than 100 megs for each of our containers, which is a big difference when you're trying to push and pull these often. And so if you look, all I've done is same configuration file that we had originally in the previous video. It's just a standard Nginx file, but I'm naming it template, and I'll show you why. I've now put in environment variables. So SDK API host and SDK web host. So now when I run these Docker files, I have an environment variable that I can inject, and it'll rewrite that configuration so that we can deploy to different hosts. And the way these environment variables are getting written is right here. So I'm passing these environment variables in from the Docker Compose file. And then I have a little bash script that uses n sub st. It's built into most Linux distributions. It comes with Ubuntu, comes even with OS X. And this allows me to take environment variable substitutions on a file. So it's a nice way to do a template. And so I'm just saying, take this Nginx template that I copied in and rewrite those environment variables that are being passed in at runtime. And that's all you need to get Nginx up and running. And then with the Node.js and the Python, it's a little bit different because we want to rip out a little bit more. So let's look at the web first because it's simpler. So I did the same thing. Now these are called multi-stage Docker files. And so this allows us to have a build step and then a production step. And you can actually run these individually. So I can say, build an image that's only the dev step, or build an image that's only the prod step. And the final result is any of the stuff I did here won't be in my final prod stage unless I actually copied in. So you can see in this line right here, I'm saying from dev, and I've named it dev up on this very first line. And so I'm saying, okay, copy the build into the Nginx folder, and that's it. I'm not copying the node modules or anything else out of the dev step. And then I'm just launching Nginx. So you can see I'm using the base Nginx Alpine. So now what I'm doing is I'm building static HTML files and then I'm serving them from Nginx. And if you wanted to build one of these yourself, you can just say docker build and then name it. And if you said that, and then you can say target equals dev. And then that's only going to run the dev stage. So you're not going to get that prod modification. You're going to stop right at dev, which means you'll get that dev server when you're running it. And if you wanted to get prod, you can do that. But if you don't give it target, it's going to run all those targets all the way to the end. So then what I did on the API level is a little bit more of a modification, but only because we had C dependencies and a lot more build environment that we wanted to remove later on. So as you can see, still using Alpine, a much smaller one. And then the package manager for Alpine is APK. So in Debian we had APT, now we have APK for Alpine. And first thing I'm going to do is get the build tools that I'm going to need for Python. GCC is a compiler, and then a couple of C libraries so that I can install stuff. And then all of this is the same as what we did in development, except I've added the no dev here. So I'm saying only install the dependencies that my software requires. If I had any development dependencies, do not install them. And then in Python, a wheel is a binary distribution of the package. So I'm saying create wheels of not only my library, but any of my dependencies. And this is going to allow me to store a compiled binary distribution of my dependencies and my API all together. And then that's all I need to ship to production. I don't need any of these development libraries anymore, which allows me to ship a much smaller image to production. And then we finish off in development or in the base by exposing the port 8000 and copying it up. So in development, we now run the poetry install. And now you can see I don't have the -- no dev. And so now I'm installing any of those dev dependencies. And then I'm going to use a different web server in development versus production. So if we go down to production, you can see what I'm going to do is I'm going to copy stuff from that build step. I'm going to say, give me all those binary files, all those wheels for those Python packages, and then also give me the binary distribution of our API. Copy those in, and then install it. And that's all we need to do in production. So when I ship this image to production, this is the only thing getting shipped. All those extra layers are no longer getting shipped. They're just used for development or to build our packages so that we can ship them. So if we wanted to run this, you can just say docker compose, and then you can tell it which file to run. So if we wanted to launch the development environment, we just say launch the docker compose dev file. And that's going to grab all of those images if we've already built them. Otherwise, it'll build them. And then we'll have our real-time development environment. But then we can use the docker compose file to also ship to production. And this really only works when you're on a single server. So if you need to scale out and distribute your APIs or your server, you'll want to use something like Docker Swarm or Kubernetes, and I'll go over that in my next video. But this is just the simplest, let's get a production environment running on a single server. And so while this is downloading the packages, I can show you a little bit more of what's going on. So when you are building these images, so if you look, we already have these images. Sontech, Nginx, Web, these smaller ones. These are the ones we're going to want to deploy to production. And so you have a few different ways that you can deploy these images to production. You can Docker push them to the Docker Hub, like I covered in the last video. Docker push Sontech Web. And this is going to push a public image up. Maybe you don't want a public image. Maybe you want a private image. You can set up private repositories inside the Docker Hub, but it will charge you. and it'll have a limited amount of pushes and pulls. So if you're doing a lot of deployments, you might run into issues there. So another option is to just save these images out. So you can say Docker save and then give it a file. So we're going to export the Sontech web image, and then if we run this, it's going to get my most recent built file. So now I have a 23 meg tar file. And then you can just copy this up to your server. So you can just say, you know, SCP, SSH copy a file from local over SSH to production. And you could just say sontechweb.tar. And then once you copy that up, what you would do, so we have these images here, you would just say docker load. Docker load -i. And so that's your input. So if you load this tar file that you saved and copied up, it's the same as doing a Docker push and a Docker pull. So this gives you a way to go around the repositories. You don't need them at all. And so we do this a lot because our deployments store all their artifacts inside the continuing integration server. So we run all of our tests, then we build our Docker containers, and then rather than pushing them up to the hub, we already have an artifact server for those builds because we're generating all kinds of assets. We build all of our HTML files, CSS, JavaScript, all of our wheels. We make all of those as artifacts already. So now we're just making one more artifact, the Docker build, like the Docker image. So then when our CI is running, it just copies up the image that it wants to load, imports it, and then you're good to go. So this is still compiling because of the C dependencies, like I said before. So this is why we do these layered steps, because this C dependency is very slow. So I have that base build image so that later on, if I want to rebuild prod, I don't have to recompile and reinstall all of those C dependencies. It just caches it, and then I can keep modifying my code, and we can keep deploying quickly without recompiling all these wheels. The only time you'll have to recompile everything is if you change your dependency tree, and then it'll recompile and reinstall, regenerate those artifacts. So then the other thing that's really interesting about Docker is they have different contexts. So, you know, I said, you know, we can copy these images up and then import them and run them. But you can, if you want to use a Docker Hub or the ECR and you want it to pull, you can actually even use your Docker Compose remotely. So they have different contexts. So you can do Docker context ls. And you're going to see, I have two different contexts. So I have default and I have remote. And if you look, my remote is an SSH server. And the way you create these, you just say, and then this is the name. So you could say prod or staging, right? But when you do this, then you can tell it to just be an SSH host. And if you do that, then you can start communicating with the Docker Hub remotely. So if I say, let's do Docker so, you know, like when we run remotely or locally, we're saying Docker PS. And that's saying, what containers do I have running on my local machine? But I can say Docker context, remote, prod, whatever you name it, and then PS, and say, do I have any containers running on this remote SSH server? And right now, I don't have that. So let's check it. Okay, so this is still compiling. So we're going to get this up in production while I'm getting my development environment set up too. So what we can do is we can say docker compose So what we're saying here is run docker compose, use the prod compose file, and use the context of that remote SSH server, and spin it up. Let's spin up our whole environment that we've defined. This is a reproducible Docker environment. So we are spinning this up remotely in production. So if I go look right now, so we're not up right now. So unable to connect. But this is spinning it up. We are now deploying to production using Docker Compose. Okay, so now we're up and running in production. So you look, we're on that IP address of that droplet, but it's saying hello world. And if we look at our network, it's making an API request and it's getting a response. And we can see that here as well. If we hit the API, it's saying hello world. So we just took a single Docker Compose file, locally, Docker Compose up, boom. All of a sudden, we have a production environment running Node.js, Nginx, and a Python API server. And you can set up cache servers and everything as well. And right now, I'm just running this, so if I Control C this, it's going to spin down that environment as well. So now if we look, production is down. Okay, but you can just say, send this command to the background, and then it'll be running. You don't have to worry about it anymore. And then Docker Compose is set up with systemctl to restart if the server reboots. So now you no longer have that problem that you had previously, where if the computer restarted or the server restarted, you would lose production. So now we're back up, and we can actually say it, Docker Compose or Docker context remote PS. Let's look at it. Is it actually running? It is. We have all of our infrastructure set up. But that's basically it when you are setting up a development environment and a production environment. There's very few changes you have to make. So you can see the split. Production's on the right, development's on the left. Most of it's using the exact same infrastructure. We just want it to in real time update in production. We don't need it to in real time update in development, or reverse. We want it to real time update in development. We don't want it to update in real time in production. If we wanted to push a change to production, we would update the image, rebuild the image, and then restart production. Alright, but that's basically all I wanted to show you for preparing images for production, is shrinking them down using Alpine or Slim, modifying your images to be multi-stage so they're not including your build tools and any other packages that you don't want, and then how to control Docker remotely. And so next time, we're going to scale this out. I'm going to be setting up a Kubernetes cluster. We're going to have multiple web servers, a database, all communicating together, and then we'll set it up to auto scale depending on the load. Hacking on containers in my tech merge, Python, Vim,